Alright, here's a nice problem. Bug population doubles every 4 days. The initial population is 8. How many bugs are there in 17 days? So what we want to do is we want to create an exponential function to model this information. And I'm going to use t instead of x. Okay? Why? Because time. We're talking about time. So do we have to use a t? No. But I'm going to do it anyway. Alright. Well, what's happening? Well, it says that our initial population is an 8. Okay? So what does that mean? That means our y-intercept is an 8, right? So initially our time is 0. So we plug a 0 in for time. We're going to have b to the 0, which is a 1. And what we're left with is going to be an 8. So I'm going to go ahead and plug that 8 in now, since I'm getting better at doing this. This is, should probably get the right caps on the right pins. Okay, b to the t. Well, now what's happening? It says the population doubles. Okay, don't worry about how often it doubles, but it's saying that the population doubles. Okay, so we're having a doubling effect. So what does that mean? We'll double 2, multiplying it by 2. So that means our base here is a 2. Right? But here's the tricky part. Okay, there's actually a little tiny constant in here. The book doesn't necessarily tell you that, it just wants us to kind of figure it out. Okay? And what that constant does is that constant helps us figure out when we have a whole value. Okay? Well, what does that mean? Okay? Well, the idea here is after one doubling effect, how many bugs are we going to have? We're going to have 16, right? After 2 doubling effects, how many bugs are we going to have? We're going to have 32, right? Okay? But the thing is, it takes us, in this particular case, 4 days before we double. Okay? So here's what I'm going to do. So I'm going to say, okay, well, I want to create one doubling effect. So I'm going to have that equal to my constant times the time it takes for one doubling effect, which is a 4. So I can figure out what that constant is by just solving for it. So k equals 1/4. So what I'm going to do is I'm going to put a 1/4 in here, right? But it's 1/4 times t, so it's just going to be t over 4. So now when I put in 4 days, right, it's going to be 4 over 4, which is a 1. 2 to the 1 is a 2. 2 times 8 is 16. Okay? If I put in an 8, because what happens in 8 days, we double again. 8 divided by a 4 is a 2. 2 to the 2 is a 4. 4 times 8 is 16. So it works out. Okay? But let's see how many there are after 17 days. Okay, well, let's put it in our calculator. I can't quite do that in my head. So 8 times 2, caret, parenthesis, 17, divide 4, parenthesis. Okay, and there is 152.219, so 152 and one of them is pregnant, bugs.